Advent of Code 2015. Jumping into day 12. JS Abacus Framework IO. Santa's accounting elves need help balancing the books after recent order. Unfortunately, the accounting software uses a peculiar storage format. That's where you come in. They have JSON document, which contains a variety of things, arrays, objects, numbers, and strings. Your first job is to simply find all the numbers throughout the document and add them together. Okay. They have 6, 2 plus 4. Okay. And so on. Blah blah blah. You will encounter your any string contains you will not encounter any strings containing numbers. Ah, okay, so within the string there's no numbers. Got it. What is the sum of all numbers? Okay, that's but we have to handle the minus case, I guess. Okay, so I can't just count all the strings or something. Let's see, let's take something with a minus. This is a good one. And try it. So we have a string. And we need to probably just run through it. Each character, then we have something like result, previous, sim, definitely previous. And then if previous is a digit, if this is a digit, then we add it. What I want to do is skip non-numbers, and then I have a number and I add it. Change this and I add this to a list or something, and then if the next one is not, well, the next one is a number, then I add it as well to a list, and then if the next one is not a number, then I resolve it. So I need some kind of list. Val number mutable list of I guess cars. Also, it will be reset at some point. Then I just look at the current one. If C is digit, then I add it to the list. Add C. If C is not digit, then if number is not empty, I have to make a number. Number dot join to string maybe, and then to int. I have a number, okay, and then I can add that to my list. No, not to the list, to the result. Then I reset number mutable list off. Now I should be able to count and positive ones. Let's check. I should have 43 plus 1, 44. Okay, now I just have to handle the minus. Which is pretty easy. I can just say, hey, indexed sign is raw I minus number dot length size okay wait minus sign is if this is this, and then I just say, hey, I want to change to when minus sign else r minus equals none, and then you can do when here as well. When let's try this. Haha. Strange, minus 44. I wonder what the sign here is. Must be colon. Aha. Also pretty silly that I did set it minus sign, I go plus. This way it should be the right way, and I need to go one further back. 2. Yes, exactly. 43 minus 1. Because in edge case the first one is a number, but I think that won't be the case. Okay, good. Let's get it. Let's get it. Oh. No minus signs here. What's going on? Okay, wait, I'm printing this wrong one anyway. Okay, that's fine. Let's try. Right answer. Part 2. Ooh, oh. The accounting elves have realized that they double counted everything red. Ignore any object or any of its children which has any property with the value red. Do this only for objects and not arrays. Okay, what's going on? Still has a sum of 6. There's something with red in this object, so we ignore it. Tricky. So because this has a value red in the object, I ignore everything else in the object and all of its children. Here it has some of null because it has a red here. I could check. Can see a way to do it with counting the wiggly brackets. What's the name of this? Curly bracket. Or you split the string into smaller strings. Check this example. Red. So well, as soon as I walk into a open bracket that has a red, I need to stop counting. If I have a 1, I can't count this one here. Depth be 1. It feels hard to actually break it down to smaller problems. So if I can kind of find this part and if I could, let's check the big one. Well, this is kind of a good example. Let's just leave it and look at here. If I could kind of find a way to send these strings down. if I could solve the problem for an object with no children, and then when I get an object, I look through it and see if it has children, and I send all the children to that function, unless the object contains a red. It'd be tricky to handle lists differently than objects anyways. Well, I can also separate that out, I guess. But I feel like, isn't it possible with counting the things? Count here, 1. Then I find a red in there and everything until the end is gone. Now, what is it if I find a red in a list? It doesn't matter. No, it definitely has to be some recursive function. Okay, let's start it. They have an object string. And if it's only an object string, what do I do now? I can just do this, right? If it contains red, then it's when it contains red, 0, else. Can this be a function? Oh, the whole thing needs to be a function. Count string, count numbers of a string. Okay, so this is a function now, so I can just say count numbers of my string. And then I have an array. this maybe, I don't know. Then I don't really care about it, I just count numbers. And then I have to differentiate. I have to do splitting. So let's say I have a list with an array or an array with a list. If contains this, then I have to split out the Oops, look at this one this time. This goes here. Next case. So here I have an array and then I have to just find this part. And I have to say var star depth equals 0 for each character. Let's go. And we look for depth plus equals 1. And then when we close it, depth minus equals 1. And if we have found opt equals can I just do this? If depth is greater than 0, opt plus equals C. Doesn't like it. Okay. And then if depth equals 0 again? No, yeah, I have to check the second time. But if I reach depth 0, This is if I reach depth 0 again, then I can add the string to I can send it to object. Okay. I feel like I don't need to count numbers over all the things then, because this, yeah, I can't count this, only the normal ones, this and this. That means I have to completely split this up again, so here object. Also to reset object here actually, and I need to remove object from the string somehow. I think there must be an easier way. By just walking through the stream. Because you're just walking through a tree. You just have to make sure how deep are you right now. As soon as you walk up, you just have to remove the yeah, I feel like it's easier to walk up and down the tree. Let's start again. In the this function. I just need to keep track of a few things. Depth. And have some kind of map. Map of int to okay, new plan. Start at depth 0. Go. I don't know how I can initialize this. Let's say 0 to 0. Is that right? Yeah. 0 to false. So I go through, if I have depth 1, so I just go through, count all the numbers here in my map. And if I'm ending, I guess my string would start with things. So I would go depth 1 immediately, right? Depth 1. Okay. So I really don't need this. Whatever. Numbers at depth. So I go deeper if depth in numbers at depth keys. It's not there. Then numbers. I initialize it. I kind of assume that it's also not in the red. Is 0, no, depth is false. And if we're going out, then depth minus equals 1, but before I do that, I have to evaluate the last thing. So if I have a wonder if I can completely ignore lists or arrays. Anyway, so if not read at depth, it's a problem. Then result plus equals numbers at depth. Otherwise I don't. I decrease my depth. Well, before I do that, I just have to delete. I don't know if I can delete. Remove depth. And red, remove depth. And then I go here, numbers at depth equals numbers at depth, and then similarly plus. And there's something else. I don't know what this does now. Let's see. Okay, in this case you're at depth 0. Then you go into depth 1, and then we go back up, and then okay, I don't know what's going on here. Let's ignore that because it's not a real example. Wait. Let's do this. Seven. 1, 2, 5, 6, 7. So it adds everything. Okay, yeah, obviously I'm not checking that. Never setting red at depth to true. Something like this. Let's see. Aha. So we can check if the next 3 strings contain red. And then so here we would check that, hey, this is red, so now we say this depth is red. And as soon as we go here, we say it's red. Don't add the numbers. Somehow I'm adding the 2 here. I'm confused. Is there any other place? No. Let's see what happens here. Depth is 1. Numbers at depth is 0 and 1. No, 0 and 6. must be at the end already. I don't know what's going on here. There. I wonder where I got the 6. Let's check that. Number is 1, 2, 3. Okay, each depth. Number at depth 0 is 0. Number at depth 0 should be okay, first of all my depth counter is wrong. I shall go 1 and then 2. I is 0. Okay, I is 2. Here, and depth is 2. Okay, we're at C now, we should almost be at R. Now we have this. Okay, this works. Depth 2 is true. ED and so on. So then we should get to this one. We removed one depth. Result is still 0. Number at depth is 1. Yeah. And now we have a comma, and then we have a 3, no? 2. Where's number 2? So we're adding 1 and then 2 and then 3 and then we have 6. We shouldn't be adding the 2. So when I'm done with the depth, I need to reset this. over. There might be something we're still missing. Let's just check it. What it spits out. Too low. Yeah. Thinking that. Let's check this edge case. Yeah, this is just 0. That's good. Let's check this. Okay, this is 0, but in our case, we would have something like this. Okay. Yeah, because this contains red. So we're invalidating it, even though it's like we would need to invalidate if it would be invalidate this one. But we shouldn't invalidate this one. In this case, it should count, and in this case, it should invalidate. We're invalidating both because we're within this and we're finding a red. Where do we do this here? Okay, we just have to check if we're in an array and not in a object. In array, not object. Then if we just need to set this. True. But if we're here, then it's false again. And if we're here's also false. And that might be it. I don't know what else could happen. Now we're counting 1. Okay, here we say we're in array not option, and here we say we're not. And then here we say we're in array not object. And here we say we're not. I wonder which one we're counting. Yeah, this one. Strange. Why don't we count the 5? true. True. Bracket. Then we're outside of it again. I wonder if this is the one that opens it and this is the one that closes it. Could just do a cheeky evaluation. Can we? Let's see. Red hat depth is false. Oops, I missed it again. One RED 5. The bracket, which means I might want to add the number here. 16. Yep. I close the bracket. Maybe not always. See what happens with the real thing. I can imagine one more edge case. Yeah, where All right. New strategy. I think what we need to do is go down in depth every time we have a bracket, regardless if it's squirrely or what's the other bracket called? Square bracket. So then here we would go up again. Oops. And then in this case we can just count the 1 and the 3. Let's see if we can do that. So move this. So I'll just remove it and start over. Or we to handle it separately. Just basically do the same thing, go deeper. But we also set in array to true. And then if we go here, in array is false. If we go out, in array is false. And we do this. But we don't care about the red. And if we go out here, we leave it. I think we need another one of these guys. You go in and you say, hey, this depth has true. If we leave the depth, we don't care. Well, we do care in the sense that we remove the depth. And we, if we're in, yeah, if we go deeper and then we have a new depth. So we're not setting in array at every depth. this. Here we have to set it to false. Well, in this depth it's just by default false. So if we do this, we have in array this depth false. And then once we finish the array, we can just add it up. Red at depth is true, we can still do that, but we don't really consider it. So let's undo this. Try what comes out over here. 1, we want 1, 3. Numbers at depth, where do we do something here? I think the difference is we're hitting this. Before hitting this, we always hit. Oh no, we don't. Okay, so we're not really summing up correctly. How can we handle this? C is digit, we add it. And then if we just have another when. If C is digit, we add it to the numbers. If it's not, we have to resolve it at the current depth. And then we change the depth if we have these other cases. And I have to move this out here because sometimes I resolve where I add the numbers. And if it's just in one when, then we might miss the last case. If we have a 2 here and then we close, we first have to add it, then we close in the same step. Now we have 4, which is 1 and 3. Yes, that's what we want. Let's have a look at this. See what we get. Now we're too high, so we're overcounting something. I wonder if there's a case where we have a red in the array. No, that's fine. I think one thing we need to still do and handle is ignore any object and all of its children. So as soon as we have an object here where we have a red at depth, yeah, I think if we're going to be checking just we added if we're not red at the current depth, but we have to check if we're not red at any of the parents' depths. Not red dot any. Like this. At any point I'm red, that means I'm either currently red or a parent is red. Because if I jump out of the parent, I remove the red at depth. Let's try this one. Nope. It doesn't give me a hint anymore. Let's go through a few more examples. Okay, so if I'm in array at the current depth, then I should never set red at depth as true. Then if when I'm resolving the numbers, I can't add them if I'm red at the depth. Or another thing I could do is I could always add it, and if I'm red at depth, I can set it to 0. Yeah, because I'm counting it always, but any. Yeah, so now I'm not setting it for arrays, and I'm checking the parent situation for arrays. Is that enough? Okay, at least we have this case solved, because I'm going here, I'm adding it up, I check is my parent red, and if it is, then I don't add it. I wonder if that's it then. Let's see. Let's check all the cases again first. First of all, I don't know if this works now. I think it doesn't. Oh, it works. Cool. Then we have this is 4, 1 and 3. Then we have this is 0, we just checked. And then we have 1 red, 5, it's a 6 because we ignore the red. Okay, let's maybe check the result again. Just have to wait a bit, I think. Oh no, this is not the right answer. What else could it be? Let's make another example. B 1, 2, 3. C red. D 1, 2, 3. Let's close it. See what happens here. 6. Okay, we have 1, 2, 3, and then red. Okay, that's correct. If I add W red. Ah. So we're going deeper here. Going up again, and we have a red, but we're still adding it. Why? What happens here? I go out. This. I have not read. I haven't resolved this yet. Just no, I haven't. I just don't. I resolved this and don't count it. I've yet to resolve this. Basically the same example would be this. Let's make it even smaller. Actually, make it even smaller. Okay. I resolve it at the end. Do I? Oh, wait. Yeah, I add this number. I resolved this and it's not marked as red. And later on I find out that it's red. That's a problem. So either I look ahead before going deeper here, if there's a red, to mark this area correctly, or I add it and then undo it again. I think it's probably easier to look ahead, even though it's less efficient, because I can't keep track of this if it goes up and down constantly. So let's do it. Yeah, I'm in an array, I always have false for that depth. That's fine. And if I'm not in an array, through the whole thing. String at index. Depth. So based on the current index, if it's this, or this, go deeper. Per index equals this. Minus equals 1, so we go higher again. If we close it, and then if let's do this. Once easy, then we go here. I have to do the same thing. Start off false. Then we have this check. So now we go through the whole rest of the string. If we go deeper, then we continue. we stop if we're at the end, or if we're going above the current depth. We go deeper with this, we go higher with this. We have in array true, array false. Don't know if there's extra cases where we go like twice into an array. Oh yeah, that's not good. Array of arrays. So then we have to say 0. This one. Only if we're in 0. No, that also doesn't work. Because we could be in a double array and then go lower. Although, that doesn't matter, I can just ignore it. Yeah, this is not important, because we only care about the current depth, or the depth. We go through all the extra depths, but we ignore those. If current depth equals to depth, then we want to do the red check, otherwise we don't care. And the outside can't be an array, then we also don't care. Then we just go through, and then we have set this correctly, hopefully. We have our example, let's see. 0. Okay, let's see other examples again. Red is 6, that's fine. And our new edge case is solved, so let's try the big boy again and see what we have now. Ooh, we did it! That was a schwere Geburt. But we got the 24th star. So let's talk through it again. We count the numbers. We just want to add to this result variable. Number is a list of characters, because we want to go through and just collect characters until we see a character that isn't a digit, and then we can sum up these and, well, combine them and say, hey, this is an integer with value 100. That's what number is for. The depth is the depth of this tree that we're building, so every time we hit something like this, we go deeper, and so on. If it closes, we go higher again. Say it's like this. Be like this as well. Closing this and then close this. So this is depth 1, 2, 3, Okay, we got the depth, and then we just count the numbers at each depth. Well, now we first have to check if is there a red at the depth. Because if there's a red, then well, let's put it here or something. Then this layer and all its child layers should not be added. So what we have to do is go down at the depth and go if there's a red in here. We don't check the bottom, just check the current depth. That's where we go. Current depth. Stop if we're smaller than the depth. So if we go up here, we stop counting. Because if we do other stuff here, we just check this layer. If we go one too high, we stop. If we go lower, we continue, but we ignore what we find. So if there's a red here, we ignore it. We stop before the end of the string, because red has 3 characters. Then we do that, we just go down, up, whenever we see these brackets. If we're at the current depth, so if we're lower, we ignore, if we're higher, we stopped, and if we're just right, we check for reds. Find a red, set red at depth to true. So then this is just for checking red at depth. If there's an array at the current depth, like this one, we don't check, because we just want to add it up. Unless the parent has a red. But now whenever we enter a new array, we enter a new depth, we check if there's a red. So here we check the parent is red, we add this up, but we don't add it because we have the parent red. So we add it, but when we close this one here, we check is red at depth any of the parents. So we add it to the number of depth, we always add it to everything. Number of depth, we resolve the minus sign and say, hey, we add it to the depth or subtract it based on a number thingy. And then when we're closing it, we add the numbers at that depth, because we're going to remove that depth. Once we're going out of the depth, we remove it again. So we can start it new again and remove it again. We add it to the result, but only if none of the values in the map red at depth have true. Because if any have true, that means one of the above layers has a red in it. So we do that when we're closing these brackets and when we're closing these brackets. This is the same now, I think. Almost. Yeah, and then objects are different to arrays in the sense that we say in array depth is true, and in array depth is false for objects with the squarey brackets, because we have that case where we want to count an array even if it has a red in it. This sums to 4. That's the small difference. So we just keep track of all that. The trick is just to keep track of everything, and then you can just loop through the string and some of the numbers and return that and print that. That's it. Thanks everyone. See you tomorrow.